This call is now being recorded.
Hello, good afternoon to Alpha. Can you hear me?
Can.
Okay, thank you very much. And then, of course, like obviously, I always ask at the beginning of the class, can you see my presentation? Can see my presentation? Can you see my screen sharing as well?
Can.
Yes.
Yeah. Okay, thank you very much for your response. Right. So, like I promised you yesterday, today we try to start chapter 8. That is force and motion. Yeah. Chapter 8, force and motion. Okay. So before we start, we take a look at the table of content on how our progress in science form 2 this year. Okay. We are still in themes number 3. If you can see my screen presentation right now, we are still in themes number 3. Themes number 3 consists of 4 chapters. Okay. And then we just finished chapter 7, that is electricity and magnetism. There are 3 more chapters to be finished in themes number 3. Themes number 3, you learn about the energy and sustainability of life. Okay. But in chapter 8, although there is only 2 subtopics, there is 8.1 force and then 8.2 effects of force, but in 8.2 there is a plenty of mini subtopic you need to cover. Okay, but that's all right. Never mind. We will try to take a look at that later. Okay. 8.1 you learn about the force, and then 8.2 you learn about the effects of force. Okay, still in themes number 3. And then we have 2 more chapter to go, chapter 9 and chapter 10, before we enter the last themes for form 2, themes number 4, chapter 11 until chapter 13. Okay, but never mind, I will try to finish it as soon as possible. Okay, and then maybe later on when you'll be able to come to the school, if you have any problem, we can try to solve the problem when you all come back to school doing the practical. Do you think, I just want to ask you frankly, frankly, do you think the school will be open on September, do you think?
No.
No, wow. Because last time, Perak, they said Perak cases continue to rise sharply. But never mind lah. This is what we call history lah. Okay. We cannot do anything about it, right? We just wait for the government announcement, and then we are hoping for the cases to decrease lah, so that we can continue live and learn and work normally. Okay, right. So chapter 8, force and motion. You can also check your textbook later, page 166, 67. All right, can we continue? I will try to what happened here? Okay, 240%. Right. Okay. So 8.1, class, are you ready? We can start now, Okay. 8.1, you learn about force and motion. Okay. So number 1, like usual, you must understand what is the definition of force. Okay. Very easy. The definition is force is either you do the work. Okay. What type of work you do? Either you have a pull or push upon an object. Okay, push and pull of object, we call it force. Just a pull over here. Okay, you pull an object or you push an object or push an object, so you will exert the force over here. Okay, number one, very easy. What is force? Pull or push upon an object. Pull ni maknanya, for example, if you look at the picture here, pull meaning that you pull something, alright? And then push meaning that you push onto something of the object, right? And then almost everything, almost every work, every activity that you do daily consists of pulling or pushing an object, right? That is number one. Okay, class, all right. Number two, the type of force. Okay, I will skip the activity over here. Okay, this is number two. Type of forces. How many type of forces there is? There is 1, 2, 3, 4, 5, 6. Okay, in Form 2 Science, you must try to remember there are 6 type of forces. Okay, there are 6 type of forces. We take a look one by one. Number one is what we call by gravitational forces, meaning that the force that point toward the center of the earth, point toward the center of the earth. Okay, can you see the force, class? Can you see the force itself? For example,
Cannot.
number one, gravitational force. Yes? Can you repeat it
Cannot.
for me? Yes, you
Cannot.
can. Yes, okay. Thank you for your reply. Okay, you cannot see force, what we call physically, okay, because it cannot be seen, but we can see the effects of the force. Okay, we can see what the force can do to an object, but we cannot see the force, what we call literally. Literally, we cannot see the force, but we cannot see the action of the force. Okay, for example, gravitational force. We can see, for example, if you throw the ball on the air, the ball will fall down at the earth, right? When you pull or you can you release the pen, for example, or you can release the pen will fall toward the earth. Okay, you cannot see the force pulling the pen, but you can see the effects of the force. We can see the pen falling down to the earth, falling down to the ground. The effects you can see, but you cannot see the force itself. Okay, so number one is what we call by gravitational force. Okay, okay. Next one is number two. We call it normal force. Now, what is normal force? Force produced when an object is in contact with a surface. That is the normal force. For example, if I have a pen over here and then I put at the top of my hand, so there is a normal force going on. There is a normal force. When the object contact with the surface in my example right now, the surface is at the back of my hand over here. The pen is an object. When I put the pen at the back of my hand, so there is a normal force going on. Okay, that is the normal force. Okay, class, okay, any object when you put on the surface, we call it normal force, right? Okay, number three, we call it frictional force. Okay, what is the definition? A force that resists movement between two surfaces. They are in contact with each other. Okay, frictional force, of course, frictional force always involve two, what we call two surface, two object, and then they try to resist the movement from each other. For example, very easy one, you have your own right hand, right palm, and then your left palm, you rub it together, okay, and then it will create what we call a frictional force. Okay, very easy this one. Okay, what are the others example of frictional force? For example, the tire. The tire in contact with the road, that is also what we call a frictional force. Okay, and then when you wear a shoe, and then the contact of the road, the contact of the ground, you cannot fall down. That is also what we call by the frictional force in action. The next one. Okay. Again, this is an example of the frictional force in action. There is a direction of motion, and then the frictional force will oppose the direction of the motion. You can see the people, you can see the man over here trying to push the box by using the force, right? And then the frictional force will against or will oppose the direction of the motion here. Right, this is the where the frictional force is in action. Okay, class, okay. Normal force. This is normal force when an object in contact with the surface. This is example, the surface of the table. Okay, you can see there is a normal force in action. Although the object, the apple over here is has a weight. So because of the apple in contact with the surface of the table, and then it is moving or not moving, the apple class. Moving or not moving? When you put on the table, move or not? What happened to the apple over here? It is move or not? When in contact with the table, move or not? Normal force.
Not.
It is not moving, right? So this is what we call by normal force. Not moving, or we call it stationary. Stationary object is the object that is not moving. Why not moving? Because it is on the other surface of the object. Okay, it sits on the other surface of the object. Okay. Next one. Okay, 1, 2, 3, and then this is the force number 4. The force number 4, we call it a buoyant force. Buoyant force is the thrust force acting on the object. The force that is acting on the object that is floating on the surface of the fluid. Such as, what is the example of fluid? Such as water, such as oil. Okay, this is what we call a fluid. But usually, in order for you to more understand, you just imagine water lah. For example, here we have a toy duck over here. And then you can see the toy duck, when you put on the water, it will not sink. It will float. Okay. So what makes the toy duck float on the surface of water? Because of the buoyant force exerting on the toy duck over here. That's why the toy duck will float on the water. Okay. This is also a type of force that one of the type of the force. Okay, class, is it okay? Right. Number 5 is the, what we call this? Oh, the weight. The weight class. Sorry. Okay. So the weight of an object is defined as the gravitational force acting on it. Every object on the earth will have the weight, right? Because the object, you still remember the matter has mass, right? And then every mass has its own weight based on the gravitational pull on the earth. Okay, that's why we call it one of the force on the object is the weight. Okay, the weight, dia punya berat itu bagaimana. Alright, so the last one, the type of force number 6 is what we call by elastic force, when material is number 1 stretch and compress. For example, the slingshot over here. The slingshot, or the what? Or maybe the archer. Okay, and then the bow and arrow lah, bow and arrow. Okay, or maybe just as simple as the rubber band. As simple as the rubber band, when it can be stretched, when it is compressed, and then when you release the object, it will exert elastic force. Okay, for example, the spring. Okay, spring also spring. Okay, any object that can be stretched. Stretch meaning you elongate it. You try to pull it. That is stretch. Or maybe any object that you can compress it. Such a very what we call a common object is the spring. A spring, you can compress the spring and then you can stretch the spring. All right. For example, here, if I can draw it for you right now, for example, the elastic force that we can able, elastic. What happened here? Okay, what happening here? Got problem. Sorry, guys. Try to. What happened here to my notebook? Okay, I will try it once again. Got a problem here. Elastic force. One of the classic object we can use the spring. Okay, spring you can stretch it, and then also you can compress it. How to stretch the spring? How to stretch the spring? Anybody want to come in to our class? Okay, please come. Okay, for example, this is the normal spring. Normal spring that is not yet being compressed or not yet being stretched. Okay, we have a normal spring over here. This is normal spring. Example lah, this is normal spring. Okay. If you try to stretch it, if you start to stretch it, it will become like this. Okay, it will become longer. Okay, this, for example, maybe when the normal spring, when you did not try to stretch or compress it, it is maybe about 3 centimeters in the length. Okay, and then if you try to pull, the spring, and then suddenly it becomes 6 centimeters. Okay, it becomes 6 centimeters. This is what we call a stretching. You can stretch. And then what happened when you release the spring over here? When you release the spring, it will become normal. And then when you release the spring, at the same time, there is an elastic force going on. Okay, this is when you stretch it. When you compress it, what happened? When you stretch it, when you compress it, the spring
Once
maybe look like, yes, it will become shorter or become longer.
shorter.
Yes, it may become shorter, about 1.5 centimeters. This is just an example on the class, And then when you push it, it will become shorter, and then still inside the what we call inside the spring over here, there is an amount of force. There is what we call has a significant amount of force stored in the spring. Okay, when you release it, it will give you what we call a force. Okay, this is what we call elastic force, whether you can stretch it or you can push it. Okay, but if you stay push it, it will become compressed. If you stay to pull it, it will become stretched. But when you release the spring, it will go back to the normal condition lah. If you release the spring, it will go back to the normal condition. 3 cm. Okay. Normal condition, got force or no? Store. Normal condition, got force or no force? Store. Got force or no elastic force? Normal condition, class. What do you think?
No.
Is there is a force or no when you when the condition of spring is in normal condition? Got or no?
Normal spot?
Yes, normal. Normal spring got force or no force?
No.
No, yeah? Yes. The answer is no, correct. Because there is no force. It will store the force either you try to, when you pull it or you compress it, then there will be an elastic force inside. Normal spring, when you did not pull or push it, it will not store any force. Okay, class? Okay, good. Okay. Type of force, finish. Okay, next one is the characteristic of force. What is the characteristic of force? Number one, the force is a quantity. Okay, make sure you can understand this here. It's a vector quantity, meaning that it can be measured. Okay, it can be measured because it is in the quantity, meaning that in number, you can measure the force. Quantity, it is not something subjective. When it is in the number, when it is, it can be measured, meaning that it has quantity, maybe, right? And then the vector, what is the vector? Vector is what we call, it has a direction. Okay, it has the point of direction. This is the characteristic of force. Mainly, okay, mainly we call it, it has a magnitude and then a direction. Direction is the direction lah, arah dia, ya, di mana dia pergi, the direction of the force. Magnitude mean the what we call it can be measured lah, how hard, for example, here, how strong, okay, how strong is the force, whether the force is strong or whether the force is the weak, we can measure it, we call it magnitude. Okay, we call it magnitude. Okay, direction, from point A to point B. For example, there is a direction in maybe not in straight line, but there is a direction from point, for example, from point A to point B. So this is what we call a direction. Okay, if you can see the picture over here, for example, this is point B, and then this is point A, right? So if you try, if somebody will try to push the box over here, okay, it will go into a direction, and then what is the magnitude? The magnitude here, for example, the quantity of the force you exert on the object, for example, here is 10 Newton. Okay, 10 Newton. Okay, the force, the what we call the man or the people try to push the box, the force is here is 10 Newton. So this is example, the force acting on the box that is being pushed. Okay, can you understand this, class? Remember too, we have magnitude and then we have the direction. All right, this is the characteristic of the force, right? Okay. Next one. Okay. This is another example of what we call the characteristic of the force. Again, we have, what is this? If I can draw, if you can see the diagram over here. So this is the magnitude or the direction. This one. Sorry. This one, magnitude or direction? This one. Magnitude or direction?
Magnitude.
Okay, good. This is magnitude. Magnitude is something that can be measured. Yeah? In this case, we have 15 Newton of force. It is what we call a magnitude, right? And then where is the direction of the force exert? For example, here we have nail here being pulled up. Okay, being pulled up. So this is the direction of the force. Okay, right? Okay, for example, here I try to read it for you. The force acting on the hammer has a magnitude of 15 Newton and its direction as shown by the arrow. Okay, by the arrow here. This is or this or this are the direction shown by the arrow. Okay, the point of application of force is at the head of the hammer, which is the area where the applied force is concentrated. Okay, never mind. You just remember the characteristic of force, including the magnitude and the direction. Must have these two things. Without the magnitude, it will go nowhere, isn't it? In order for you to move an object, you must exert motion. You must exert the force. What type of force? We just learned right now. For example, this one. Example of force here. For example, gravitational force. There are 6, right? And then there are what we call frictional force. That is the force that exert onto the object in order the object to move into one direction to another direction with a magnitude, right? Okay, number 3. Any problem before I start number 3? Is it okay, class?
Okay.
Okay, okay, right. Okay, number 3 is the measurement of force. Very easy. I will skip this. Okay, unit of force, very easy. I think you must remember this. In Form 1, you already learned about this. The unit is Newton. And then the symbol is capital N. Okay, this is the unit, the SI unit of force. And then also, do you still remember the equation here, the conversion here, meaning that 1 kilogram equal to 10 Newton. Okay, and then if there is 1 Newton, of course, it is equal to 100 gram. Okay, you must remember the equation or the conversion here. Okay, when the question asks you what is the SI unit of the force, you said it is Newton. Okay, right. So what is the tool? If you still remember in Form 1, what are the tools that we can use to measure the force? We use, what is this? We use what, class?
String balance.
Spring? Yes, spring balance. Okay, we use spring balance to measure the force. Okay. So this is the weight. Weight in gram. Weight in gram. Okay. If you want to measure the weight, if you want to measure the mass of an object, you use kilogram. Okay. But if you want to measure the force, you use Newton. But it is kind of same actually. 1 kilogram again equal to 10 Newton. Right? Okay. Number 3, what we call it? How to measure the force, right? To measure the force. Measurement of the force, right? Okay. So this is A, weight of the object, and then B, the frictional force. If you try to know what are the force exerted, the frictional force exerted on the wooden block on the surface of the table you are using. Also, you can using spring balance to measure the force. To measure the force. What type of force here? Frictional force, right? I will skip the experiment. Okay. Okay, number 4. Action and reaction pair. Now, what is an action? What is a reaction? You must remember every action there is a reaction. Okay, that is what we call a basic rule in physics. When you exert something to an object, the object will become what we call something happen to the object when you exert force. What are the action? What are the reaction? Huh? Okay. Observe the object in photograph. Why do the object remain stationary? Again, class, what is stationary? Stationary move or cannot move?
Cannot.
Yes, it do not move. Yeah, do not move. Why it do not move? Because there is no force exert on it. There is no force exert on it. For example, the green apple over here, it is a stationary object because it sits on the surface of the book. And then the book also do not move because it sits on the surface of the table. So this is normal force lah, yeah? Huh? Okay, it does not move. A car, for example, also do not move. Okay, because there is no force exert on the wheel. When there is no force, so the car will be in stationary. Okay, so what is action and reaction? Okay, there are three different situations to explain this concept. For example, here I will try to explain this one by one. Okay, again, a book remains still a book will remain still on the table, experience gravitational force as weight. At the same time over here, class, a reaction force called normal force will exist in the opposite direction. Okay, the book remains still on the table because the magnitude of the weight, this is the action force, the magnitude of the weight as is the same as the normal force, the reaction force. That's why it is not moving. The book is not moving because the reaction force and the action force is in the same magnitude. It will not move. Okay, next example, action and reaction force. Action and reaction force. Okay, when you put something on the surface of the water, there is an reaction. There is an action force. Action force here is the weight of the object will try to go toward the what we call the center of the earth, will try to go down. This is the action force. And then the object here stay afloat. There is no movement. There is a stationary object here because there is a reaction force by buoyant force here. Yeah? Buoyant force will try to stop the action force so that the object over here will stay afloat. Right? This is what we call an action and reaction force. Okay. My question is, class, this is in the same forces, same magnitude. What happens if you put another object here and then suddenly the action force here become more? What will happen to the object?
Sing.
Same or what?
Sing.
You try to put class, remember, please understand me. You try to put another force here that is heavier. You try to put heavy object over here. The magnitude of reaction force and action force is still the same or already different?
Different.
Different, right? Yes, correct. And then when there is a heavy object you put at the top of the object here, what happened to the object here? It will sink or float?
Sing.
It will sink. Okay, so that is the reaction. That is the action force. If the action force If the action force is more than the reaction force, then in this case, the object here will sink. Okay, but if same magnitude, all right, the weight, the action force, the weight on the action force and the buoyant force of the reaction force is same, so it will float. And then it will become stationary and it will not sink. Okay? You just try to read it yourself later on. Then if you have any problem, you can ask me. Yeah? The next one. Situation number 3. We have two trolley here. The first and the second trolley, and then you can see at the middle we have a compressed spring. Okay, we have action force over here and reaction force over here. What happened when you release the toy? What happened when you release the trolley? The trolley will be moving, right? Will moving one to the left and then one to the right. Okay, so this is what we call the action force and the reaction force. Equal. This is unequal. All right, equal. So if the reaction force and action force is equal, so the first trolley and second trolley will move at the same time, same speed, and then same distance. Okay. What happened? Okay. What happened if for example, what happened if the first trolley is a bigger trolley? Bigger trolley. Bigger mean it much heavier. Okay. The action and reaction force same or different right now? What do you think the reaction, the force, the reaction force and the action force, is it same or different?
Same.
Class? Same or you have, I changed the first trolley into the heavier, bigger trolley.
Different.
Bigger wheels, bigger trolley and heavier trolley. Okay. Still the same action and reaction force or different?
Different.
Different, right? So if different, what we call different reaction force and action force, what will happen to the second trolley, you think? What happened to the second trolley in terms of the distance? Which trolley, when you release the trolley, which trolley, first or second trolley, will travel longer? Second trolley or
Second.
the first trolley? Second trolley, right? That is when one of the reaction force is different, so the second trolley here will travel longer, and then the reaction force on the first trolley will become the distance it travel will become shorter. Okay, but when the first trolley, second trolley same size, equal action and reaction force, right? You try to read it first, and then if you have any problem, you can ask me, right? Okay, we finished 8.1. Okay, like I said just now, if you have any problem, you can ask me on the Telegram group. And then later on, I will try to give you the exercise on our Telegram group as well. Okay? Any problem?
No.
Do you have any problem? Sorry, I can't hear you. Wait, I just raised the volume. You have any problem, class?
No.
No problem, yeah? Okay, very good. So what we learned today in 8.1, what do you learn today? 8.1. What is the topic 8.1, class? What is the topic for today? Force. Right? Okay, number 1. What is force? Is it true? Got two action. What is number 1? What's number 1, class?
Push.
Okay, good. We have push and number 2 is pull. Okay, push and pull. Right. Number 2, we already learned about type of force. How many? You must remember 6 type of force. Okay, right. Number 3, we also already finished the characteristics of force. Okay, meaning that it has a magnitude and it also has a direction. Okay, magnitude meaning how strong the force it apply, how weak or how strong the force. Direction maybe from point A to point B. Huh? It is not exactly straight line here. When you apply the force, the object may be swirling around, got a corner. But the important here, the direction from point A to point B, not just in straight line, yeah. Maybe got some bending or the swerving, but never mind. The most important thing that it has direction, yeah. Right, number 4. Number 4, unit of force. That is Newton, Newton. And then you must remember 10 Newton equal to 1 kilogram. And then what are the instrument that we use to measure force? Usually we use spring balance. We use spring balance. Okay, and then the last one is we learn about the action and reaction pair. Action and reaction pair. Okay. There are 3 examples. Make sure you can try to understand with the textbook in order to understand what is action and reaction pair. Okay, class? Is it okay? Can you understand this?
Can.
Can, okay. Later on, I will try to give you some exercise on the workbook. You try to do the exercise on the workbook later. Okay? All right. So, I think I will stop the class here. So, we'll be meeting again on tomorrow. Tomorrow, I will start at 11 in the morning. Can, class? Tomorrow, 11 in the morning. Yeah, we'll continue 8.2. And of course, if you have any question in 8.1 topic, we can also discuss the question I will give you later tomorrow. Okay, class? Okay.
Can.
All right. Thank you very much. So I will stop here. See you all again tomorrow. Thank you very much. Bye-bye.
Thank you, teacher.
Thank you. Bye.
Bye bye.
Bye-bye.